Alright, it seems to be active. I'm live, I'm public. Excellent connection, that's good. We'll move that window, oops, over there. Uh-oh, and so it begins getting messages from something. Probably YouTube being like, you're streaming. Yeah. So that's on there. Then I want to also do another thing. Kind of want to move that one there. Close that thing, and I'm also going to hang out in a work along thing, because why not? Capture moments. YouTube is introducing me to all these streaming stuff, but I kind of don't want to get into them while I'm streaming. It would be sort of nice to have like a trial stream, I guess. But I didn't see any options for doing that. I was kind of surprised when it went live because because it said like you'll get the chance to review everything first. Let's see, where is the thing? I want to go into it. There it is. Right, I think I'm sort of ready. Well, except I don't have any coffee. That's weird. Alright, I thought it looked like my stream has completely frozen. But it says my health is, well, my stream is healthy. Oh, how do I get a link to my stream? Copy video URL? URL? So the first thing I want to do is that I want to have a look into a message router, a fairly simple one. So I was thinking about how to create my messages, and I think I want to first make like an informal sort of definition of it, and then formalize it a little bit. I'm also going to put this somewhere on GitHub, and I can, once I've done that, I can put a comment on my stream or pin a comment or however it works. I haven't. This is well, maybe it's not the absolute first time I do YouTube streaming, but it's been years, I think, since last time. Message must have an origin, must have a type. This is so that we are able to ignore messages we send out ourselves. Must have a type. This is for to be able to do basic filtering by subscribing to certain types. Then we have message types. And here is a bit of a tricky thing, because if we look at an overview, we may have like an internal message for like registering a new client or like subscribing, creating subscriptions to messages. But then we'll also have the messages that run into whatever user space we run this into, which could be stuff like read a value synchronously, read a value asynchronously, and send that point to point. So I guess we need to also figure out message routes, which could be point to point. It could be multicast to, I guess, broadcast. There won't really be any multicast in this implementation. It could be point to point or broadcast. I guess those are the only ones we'll support initially. So a broadcast message must have an origin and must have a type. Well, all messages must have a type. A broadcast message must have an origin. No, all messages must have an origin too. But a broadcast message, a point-to-point message, must have a target. May have a payload. Type, origin, payload, target. Yeah, I think that will cover like a lot of things. So then I think that I want to switch place here on these things. Oh no, do I have flicker? That looked flickery. Maybe that's just how it looks. So we'll have abstract message. And I guess it would be a nice thing to just base these on data classes. Then we do fields, if I remember correctly, we'll notice. Type, which should be a string. Origin, which should also be a string. Payload, which is optional, but that could be sort of whatever, so that'll be an object. It has to be, we have to be able to convert it to a dictionary if we are sending it using JSON. But we'll figure out that part later. So let's see if we create one of those. So because payload is optional, is that just that I need to assign it to something? Target follows default argument payload. Ah, that's because we derive from that there. I guess we have to do something like that in that case. I don't really like it. We would have to make it like so. Type origin target. Looking good. Then I think that they will have like a protocol I mean, we do have the transport, and then we have a protocol on top of the transport, but then you could also consider the whole thing a protocol in how things talk. I'm just trying to see how I should abstract this so it becomes clear. So we need like a serializer, we need to put it on a wire. So let's make a new line delimited JSON protocol, or should I call it protocol? Serializer? That's a mouthful. New line delimited JSON serializer. And we shouldn't be able to, we should be able to do this completely stateless. So we can use static functions. New line delimited JSON wire, I guess. So if we want to write, I guess here's also like if we want to create a string or if we want to write it to a file, we may want to do things differently. But I think I'm going to start with 2 bytes and from bytes, because those would be the most basic ones. Though when we do from bytes, we always have the risk of having partial messages. So we need some way to do this in our protocol. So maybe our protocol should always return first a list of messages that was there and then whatever is remaining. Or maybe it should be an iterator, and you iterate through it, you get messages, and then you get like a special thing that means that it's remaining bytes, a special internal message. I'm not sure about liking any of those solutions. Yeah, I think a list followed by remaining is probably a good idea. And we should probably have a list of messages here so we can encode multiple ones if we want. Or maybe we should do it like this. So we can add multiple ones if we want. Now we need to also turn this message into an object compatible with JSON. Okay, let's make this a class method. Method. And then we'll call cls.encode message return result plus our new line, of course. So in our test we'll do something, we'll need to testing import messages m dot broadcast message some message some source. This is my payload. .2 bytes MSG has no encode message. Encode message. Message. So what happens if we do get state on a data class? Oh, that's pretty nice. We can work with that. We just need to worry about whether some of these attributes would incorporate weird stuff and also do some basic checking so we don't yeah, so that we follow our protocol. And well, I don't know if we should copy it. Now we'll start by using it as it's intended. Assert is instance type str is instance origin, and then payload equals message.payload, and here we need to have encode because this is not a message, this is just a primitive. Well, may not be a primitive, it's a data object, so we'll call it encode object. Encode object, and if is instance msg dot m dot, I have something in my buffer. So if it's a point-to-point message, then we also need a target, which should also be a string. Then we check the payload. We don't need that. Encode object. Should that be a byte? No, that shouldn't be a byte string. That should be something that is JSON serializable, so that should probably be a dictionary. But here is where we have to decide how we want to do this. So if it's a data class, we'll deal with it in one way. But how do we know if it's a data class? I want the test to have a payload that's just like a test thing, which should be a data class. And it will have field, because I have fantasy. Let's call it index and value. And we create a test thing here. 1, 2, 3. This is my payload. I think data class here is a function. But there is probably, let's check a base of a thing. I guess we can just check the base of this thing. I guess we need to go to the class. It's just an object, doesn't have. That surprised me. I'd expect the data classes to derive of some something else. Okay, so instead let's do match ob case string. Then we just return it. Case int, well I guess case string or int or float, we just return it. We'll just make very rudimentary support here. Notice also that boolean is a subclass of int, so that will work too. Bytes here is trickier, and that's something I want to support, but then we have to encode it. And what's the best way to encode bytes? I think we'll use base 64. But here is another problem now. When we decode this object, we need to be aware of what the original type of value was. I guess it depends on if we want to, if we are good with being destructive or not. Because the idea here is to get JSON compatible objects only initially. So we'll only support things that may be in JSON then. So if it's something else than this, well I guess if it's an object, we'll simply return, or we'll try to return encode object No, let's not do this. Let's instead just assume that we created this as a dict. We don't do that. We don't do that. And here we really don't need to do anything other than running JSON on it. Turn JSON.dump ob. Actually, we don't even do that. We just return the object. We don't need to do encode object in this case. This protocol doesn't do encoding because it requires all payloads to be JSON compatible. So then the next step is simply JSON.dumps and now it's like, how do we actually put these messages on here? And I think that we don't need a structure for the messages themselves. So if it's a point-to-point message, we'll do p msg.type, msg.origin, msg.type origin target payload. I'm starting to think about, well, maybe I should put a timestamp on it, but then on the other hand, I don't think that's... I think I need to keep it simple for now. Probably a good idea. Alright, so P, type, origin, target, payload. We should also define this in a slightly more... Didn't I have... Yeah, here was some. Okay, slightly more formal description. Point-to-point message. Broadcast. That will be B. That will be B. Origin, it doesn't have a target, it may have a payload. I guess we can use a match here. Match MSG case point-to-point message. Broadcast message. Type origin, no target, payload. Otherwise, raise exception. Oh, let's call that one unhandled. And we'll make a very unhelpful error there. Oh yeah, because now we get it in as a string. We need to also make it into Unicode. Dot. Alright, that may have worked. No, that... Yeah, that looks alright. So let's create two messages, M1 and M2, which will be a point to point message. Other message, other source, some target, 456, hello. Oh, did I have a small 2? A lower 2? I kinda like to have a lower 2. Oh, do we reference? Yeah, we're doing crazy stuff here. Message. So then we have some test data here. Now we need to see if we can get it. So we'll do from bytes. We'll do just the 5 first bytes here. And we'll do messages and remaining equals that. buffer, and we'll do while buffer. Let's not call it buffer. Let's call it buff. While buff. Message sep buff equals buff dot separate, I think. No, partition. New line. Print m message. If sep. If we have separator, then we have a message. Else we have the remaining buff. We should break then. We can't break? Oh, I forgot the thing. Return message list, I guess result, comma buff. Result is an empty list. I guess we could just append the messages here. We didn't get anything back. So that's where it is at first. But we don't get sep, right? Oh wait, if sep is nothing, then it's in message. Messages remaining. The idea here is that we can call this function now and then as our buffer is building, and then we'll get messages if there are any. So now we got one message. Now we got both messages, and then we can add some stuff here, and that ends up. That's the way I wanted it. Now it's just that we don't decode the messages. And that means this must be a class method that takes CLS. And we must make a function for this, decode message. So I guess we start with JSON.loads. I think we can load directly from bytes, so that's nice. I know I can't dump it directly to bytes. Maybe there is an option for that. So we can match this message here. And if it's a broadcast message, then we'll have broadcast. MSG type, MSG source, MSG payload. Or we could have the point-to-point, which will also have an MSG target. Should it be target? Should it be destination? Source dest? I think dest is better. And unhandled, raise exception. That's also a thing to consider later. Like if we receive broken messages, should we just crash? Should we still assume that they are new line separated? Like there are lots of different things to take into account here, but for now it will just be early fail. There is a cat here. m.broadcast message. And we can, I think we can just take those things there. Same here. Point to point message. Message. Source. Msg dest. So we have some message from some source with the payload. And we have the other message from other source to some dest. Nice. So I think the serializer is good to go. Let's make a repository for this. Not the gist. Repository. Message hub. Simple message hub. Router. Simple message router. No, that's not the name. Simple message router intended to be used for controlling E for L2 devices, human interfaces, machine interfaces, and so on. Oops. We should grab an ignore from somewhere. Maybe from here? Or we should at least grab the editor config. And .get ignore PyCache. Why do I have a server.log? Did I create that? I don't know if the logging module creates. Yeah, it does. I have a file handler there. Let's put them in logs, make a directory, and ignore it. Initial commit. Git remote add origin github.com. Mikael Lundqvist. And I called it simple message router.git. Git push upstream origin main. Boom. Well, it's not much to look at, but at least it can be looked at. So where did I put my YouTube? There it is. Okay, so current project. Can I pin this thing? Pin message. Message is pinned. I might have to make coffee soon. So what's the next step here? Yes, this is a bit messy and unfinished. I do have the other... uh-oh, Discord is loud. Did I forget to mute it again? I did. These things happen. Yes, I have this other project here somewhere. Probably on this side. Yeah, this was a previous experiment that was kind of hard-coded in a lot of cases, at least with the protocol stuff. But this was specifically for doing control of v4l. But I want to have a more, we call it like spanning, more overarching protocol for this, because I want to be able to hook up all kinds of stuff that should be like fairly low latency and also fairly small messages, but that you may want to broadcast a bunch of stuff. Because you may want to have a knob somewhere that controls a thing in your home, and then you may want to have a different knob somewhere else, and they both control the same thing. So when you turn that knob, let's say that's a virtual knob like a display, when you turn that one, the other one needs to turn too. Of course, if you'd have two real knobs that doesn't have motor control, then you'd simply have to have some way of saying like the last one you touched is the truth, or have some other way of switching between them. But that's out of the scope for today's exercise. Did I create logs? Yes, I think I did. So we can run this thing now, and it will listen and accept connections and register those clients. And I think that once a client is registered, well, I think there needs to be handshaking. So when there is a new client connected, we need to get some information about this client, like what is this client's name? So we have a lookup table for file descriptors for connections, which is good for certain things we need to do, especially if we want to know which client it is based on ePOL results, I think. So we probably need to define some sort of like system messages. Though I don't know if I need to send anything to the client. I guess I should send a message that just says... Though I can't address the message to the client until I know who the client is. So I need to break my own protocol if I want to do that, unless I allow like system messages. Okay, let's do system messages. They need to be, they don't even have I guess they is similar to broadcast messages. I guess the only difference of a system and a broadcast in this thing here would be that the system message is reserved for the system. So I think we'll have a specific messages that would be like so you connect to the server sends you a greeting and tells you who the server is. So we'll call it server greeting. And we may not specifically have a payload, we'll have a server name. And we could possibly have some stats. Server connections. And also, like, name is not necessarily the same as the key. So an origin or a destination is a unique key on the message network. And this key could typically be constructed from like the machine name, listening port, service name, or whatever things we may have there. So we'll have the server key, or like the server identity, server ID, identity. Connections, connection count. I don't know if we need anything more here. We could add that later on, breaking the protocol. Server greeting. Type origin. We haven't created a server ID yet. Temporary server ID, I'll just call it. Oh yeah, we don't need the identity, we already have origin. So this is the message we want to send. Client socket.send all wire dot encode bytes that message. From new line delimited JSON serializer import that stuff. Now we need to connect with something. Here's probably a good start for testing. Test client. Localhost 7710. AF inet suckstream connect. We need a wire. Wire equals that. And we need a thread that reads from here. Well, I mean, this can be single threaded, so let's just do it here. While true. Sock.resv buff is that. Buff equals I also wonder, like, if we receive a big message, like, we don't want to wait for it to fill up if we send a small message. So I'm not really sure how we deal with that, but that's a slightly later problem. So use from bytes, buff, messages, buff. For m in messages, print m. Let's actually put that one over there. Doesn't have encode bytes. It's a 2 bytes code. Oopsie daisy. M is not defined. We'll probably need that here too. Server greeting doesn't have payload. Yeah, I forgot to implement some of these things. So it's type, origin, then connection count. And we call that a G, message type, message origin. I guess a server greeting doesn't really need a type either. It only needs an origin. Now we may have changed the order of things. I don't think it's good to utilize uh, extensions here or bases, because I think it's better to keep these data classes as single things, because then we can make sure the order is proper. So then we don't even need abstract message. We need, for the server greeting, we have origin and connection count. For broadcast message, we have an origin, a type, and a payload. And for point-to-point, we have origin, type, destination, and payload. And we don't have this one. Server greeting, and then we have client greeting. Which is, it will of course say who it is, and maybe we'll have a description for it. And we may add more stuff here later, like what sort of client is it, what function does it have. I guess we can have like a function ID here, function description. So we need to make sure these are properly implemented. Broadcast message has type. Nope, it's the origin first. Type origin, type origin. Type, no, type origin payload. Then we have the greeting, the server greeting. Let's call that SG. And it has the origin. It does not have the type, origin, and connection count. Then we have client greeting, which has origin, function, and description. And then of course we need to do these in reverse in encode message. So server greeting greeting is SG, origin, destination. No. Origin, connection count. Then we have client greeting. CG, origin, function, description. And here, when we assert things, we should probably do that for each subtype. So payload is used in point-to-point and broadcast. Point-to-point and broadcast. We do get some repetition here, but I think that will be the easiest way of doing this right now. And then we have, if we have a destination type origin. So let's see, the broadcast has type origin. So we'll check those there. Point-to-point has type, origin, and destination. The client greeting has the origin and the function, which should also be a string. And the description, which should be a string. And this one should have an origin and an int. So, connection count should be an integer. I think that's an improvement. Greeting takes 3, but got 4. Yeah, because I've changed things. Yeah, we don't need to specify type there because it is already a type. So it's the ID and the client there. I wonder why we never fall out of that one. Do we keep getting nothing? Received equals that. If not received, then we break. Because that's end of stream. Let's try this again. That works. We did get a server greeting. This one didn't have the ePOL stuff. Is it just import ePOL? Is that it, how we do it? No? You import it from something. From select perhaps? From select, import ePOL. Let's have a look in the old code. think I'm looking at the wrong place. Test transport server. Here we have stuff. Oh yeah, we import select and then we create ePol from that. But I thought we made this thing. Yeah, I guess we never did that thing. Because we did make an event file descriptor. We should do that thing, and we do import select already. Ah, wrong file. So now we got one greeting there from the server. And now what? Well, now we're... Well, we should answer it. And the slightly tricky thing here is that, so like if we're running this as a synchronous thing, we can just read a message, handle it, read a message, handle it. But in a different, if it's more asynchronous, we could have it, we could have one thread that is doing the communication and would just yield messages or like handle them somehow. So when we connect here, we're not yet connected. This should probably be a class in a bit, or like registered false. So if registered and if not. We should only handle certain messages depending on. So if we are registered, we should handle everything except the registering or like the greeting. And if we're not registered, we should assert that it is a greeting. Because that's the only one we can handle there. Connected to server msg.origin, which currently handles msg. What's the connection count? Connections including ours. Currently we're only doing socket traffic, but later I imagine there could be different interfaces into the network. Connect to server, which has and then you're registered. And we'll store the origin of the server there. Then we also need to well, I guess we can check it for being false. If registered is false, else assert not is instance server greeting. You can only have one of those. Connect to server temporary server ID. 2 connections including ours. Is that because we are leaving them there? Yeah, we're not cleaning up. That's not good. Yeah, we never have any client disconnected here. Why though? Shouldn't we get an event for that? I guess we don't have this thread that actually does that stuff. We only have the listening thread. Yeah, we shouldn't run register client here, I guess. Though we don't know about it otherwise. Why do we create an event there? Is that just so that we know that there possibly is a client? We'll just start with something and see what happens. That one is not called EFD, that one is called event FD. We don't have a subscription thingamajig yet. I guess we call those clients, but maybe we should call those sockets. Or client socket. I guess we don't need that print there. We can use the logger info thing there. Oopsie daisy. Message routing thread aware of new client. But I don't think it has to do anything yet. And here we should try to read some data. I haven't set buffer size yet, we'll just do like this. Received data equals that. And here we need to use the wire again. And we can do this the same way as we did it on the test thing here. Though this is tricky, this buffer needs to be different for every client. So this is not really ready here. This needs to be a client specific thing. You should probably make a client class. Or like an endpoint. Okay, this is getting a bit complicated, but I think it's good. And this endpoint, we could use it for client as well as server, I think. let's call it remote socket or something, so that it doesn't interfere with just the library socket. Process, or like read data, receive data, self.buff equals nothing. So here, self.buff plus equals received. If received, well, if not received, then this was reset. Which means we should unregister this. And we should possibly later have that we can add like a list of things that needs to be notified if this endpoint goes away. But for now, just call its own unregister function. I guess we could have a reason here, like connection was reset or whatever, but let's just do client disconnected. And then it can, of course, just... it doesn't need to do anything more. I guess it can return. Plus equals received messages and self.buff equals wire from bytes self.buff. For msg in messages self dot handle message msg. That might work. Maybe we should start simple, make a test where we'll just set up an endpoint, or like we could set up two sockets that are connected to each other. Test endpoint. I accidentally named it PyPy. So this one, well, socket. And I guess handle message could be different depending on if this is a client or a server endpoint. So we could just create derivatives of it later, extensions. Endpoint self.socket got message. Import endpoint, and we also want to import the thing as a wire. Self.wire, wire, self.wire. Endpoint 1 equals from endpoint import endpoint. So it's an endpoint with a JSON wire and socket 1, then EP2 is socket 2. In Python, how do I create two connected sockets with two connected socket pair, right? S1, S2 equals socket dot socket pair test endpoint. Self.wire dot 2 bytes message self.socket.send. I keep forgetting if it's send all or send. It's so annoying now with ChatGPT. They've changed something. So if you abort the response, you can't ask a new thing. You have to regenerate the broken one. How do I abort a response without require regenerate in order to send the next message? I want the ability to shut you up when you have already answered my question. No, when you press that, it used to be like you described, but now it will say an error occurred and the only option then is to regenerate. If it is by design, it is rather terrible, considering the whole point of LLMs is to increase velocity. I prefer the short one. I didn't even read the long one. What was I actually going to ask? Yeah. So, what is the difference of socket send all via send? Send all is what we want. ep1 dot send message m server greeting, some server, 5 connections. ep2 dot receive message. Okay, it's receive data. It did get a message there. That seems to be working. I guess we could also make iterables for the endpoint. You can just iterate on it and get messages as they happen. This could of course be done with a queue. I guess we could have different endpoints for such purposes. So what happens if we do ep1 dot disconnect shutdown? Oh yeah, socket. Disconnect. Shutdown socket dot both. Python socket both. Shutdown shut rdwr. So it has to happen twice. We need to read it twice. Oops, I think it's closed. We get 2 disconnected? That's weird. Oh yeah, if we don't shut it down, it will just hang on received data. Because we should only call it if we know there is data to be received. Oh yeah, maybe epoll hub always handles when it is disconnected. That's also something to figure out. Maybe we could start to incorporate the endpoint into the actual main project. Where is the client socket? It sets it to the socket, but we should create a new client here. A new endpoint. Client endpoint. Which will have the clients will have wire and the client socket. From endpoint import client endpoint. We'll just what do you call it? Extend it. But we won't do anything now. At least not anything different. Client endpoint wire socket. Then we send a greeting. But now when we have this client endpoint here, we could do client EP equals that. Then we can do client EP dot send message server greeting. This will never work. Test client. Okay, it sort of worked, but when we... Oh yeah, we still are not using this thread. And this should be the client EP. Client EP.socket.close, or maybe it should be client IP.close EP. And it pops it there. Unregister client EP. Maybe something like that. Client EP.receive data. Oh yeah, we still are not actually starting this thread. Duh. Message routing thread. Threading.thread message routing thread.start. Should be a daemon. Group argument must be none for now. Target. Server listening, client connected, message routing thread aware of new client. Ah, clients. We did have the client FD loot. So let's see if that works better. Oopsie daisy. It just keeps. I guess it just keeps having hop. But we don't have a client EP.close. Maybe it had an error, but it scrolled way back. And then when we read it and it's empty, we get the client disconnected thing. Because we're calling this unregister here. I'm not sure we should call unregister here. I haven't really decided here. Maybe it should just be self.close, which would be def close self.socket.close. Okay, now nothing happened. Or maybe it did, but we didn't see. No, it should print if it does. We do get a close thing there, but I don't think that triggers the hang up. We also do have the connection reset error, but here Hangup would handle it apparently. Maybe we should write to the event file descriptor that something has happened, and then whenever that happens, we should just go through and see if anything needs to be cleaned up, if anything is closed, should be removed. I guess we could use event FD for special cases, so it could be a 0 here. If value equals 0, else message routing thread need to look into. Is this always a number? It's a big sort of integer. So it means we could encode both. We could encode some stuff in there if we want to. But for now we'll just assume that if it's 0 it means new client, if it's non-zero it's a file descriptor. Client connected. Why didn't this receive anything? So event write 0 doesn't work. Yeah, it's a counter, so we should probably not use that for that other thing. I think in that case it would be better to use a queue here for what's going on. Though it would be kinda nice if we just so this is not implemented yet. So that I'm speaking in unfinished sentences. Unimplemented notification to do. Should we do this? So I was thinking that we could create a synthetic event perhaps and put it on here and put a equal hop on there. Can I do that? Let's ask the Silicon Oracle. Can I put synthetic epoll event such as an epoll hop on a FD if it closes without hang up. Let's see what it says. No, you cannot. Ah, dang it. If you close the FD, epoll hop will naturally be triggered and polled. Well, it wasn't, was it? Because here we called close. Let's close the socket there. Yes, we'll try it. Then we connect again. Nope, it does not. Calling close on the socket does not trigger hang up. Oh, you can do epoll RD hub. That seems useful. So we have then we need to select what things we're listening to. Oh, there we do. Epoll air and epoll hub. We haven't checked epoll air also. This unregistered client should do the client FD pop for us. Yes, it does. So we don't need to do that ourselves. Where do we register the epoll? We do that here. Maybe we should do that in register client. And then we'll unregister it in the other thing. Okay, so let's try the RD hub as well. RD hub. So if we get RD hub, we don't need to close it. We just need to unregister it. Oopsie daisy. Well, that almost worked. Oh, it tries to get the peer name from a closed socket. Last known, or like, yeah, let's have peer name there, or like socket peer name, and we'll assign that when it starts. Endpoint self.socket peer name equals remote socket dot get peer name. That might work better. -1. How do we have a file number of -1? Is that also in remote hub? 78. Yeah, we should probably use set a file number there as well. So instead of this, we'll have client ep.file now. Socket file now. Guess we can just do that. File no. That's looking good. And then in endpoint, we'll also create that self.socket file now equals socket file now. What now? 78. Epol unregister. Did we do that more than once? Epol. We do the unregistered there. We don't do it anywhere there. That's interesting. What did we get before? That it didn't have we got -1 from the file number before. Maybe we should go back to that. But then just do... No, that's not good because we need still to get rid of the client there. Now we ended up in a weird state. Socket file no. If file no socket dot file number is not -1, or it's not -1, Then it will unregister it. Nice. Client connected, client disconnected. We're not getting any messages yet, but maybe we're not sending any. So this test client should also use our endpoint, of course. So it should have a server endpoint, which will also be just the same thing right now. Server endpoint, test client, EP equals server endpoint, wire, sock. So we connect, we create this thing, wire sock. We don't do any of that stuff. We do EP dot receive data, which should yield the first message. But right now it will just print it, I think. Yeah, it just prints that it got a message, but that's a good start. Key error 8. Oh, it disconnected the same thing twice. How does that happen? We should try this though, because that's a failure mode. Let's print all the different events we get here. Because maybe it triggers multiple events. We got an in, and we got a hop, and then we got the RD hop. So after the hop, it closes, and then we get the RD hop. So let's do if this file number is not -1, it does that thing, else, and then it sets it to -1. So that way we know that we have popped it. So we do get 2 client disconnected notifications though. So I guess we can simply put that into this guard as well. Okay, now we want to not see all these things it prints. Oopsie daisy. Seems good. From endpoint import server endpoint. Got message server greeting. So the server endpoint, I guess this depends a bit on how we want to deal with messages. Do we want it to be a queue, or what do we want? So let's say that the server endpoint will use a queue. So we'll import a queue. Then we do self.pending messages.put. Though we could get in serious trouble here with blocking stuff if we don't handle it. Though we would get that problem from the client side, so it's not a big deal, I guess. So we could do a receive data. Yeah, maybe actually I don't want it like this. Hard to decide. Maybe handle message should be like a callback, because the client here, it uses an endpoint for the server, but to be a client is more than just being an endpoint, because you need to have a thread that reads things from the server, for instance. Unless we're always reading one message at a time, which I guess we could do. We could have a function that calls receive data and then just puts the messages on a queue. And that doesn't even need to be a real queue, that could just be like a list of unprocessed messages. And yeah, I'm not even sure we should differentiate here. To be determined, should we even differentiate between roles? Or should we, or perhaps we should just deal with queues or other methods for sync. So greeting is this thing, print greeting. Connected to server greeting dot origin. Then we need to respond in kind, send message client greeting. And I guess when we greet, maybe the client should greet it first, because if the client says like, hello, my name is blah blah, then the server could say that this name is already used. and decline the client. Because otherwise we need like server says hello, client says hello, and then server says whether or not it was okay. So what was I just thinking? Alright, I wanted to reverse the handshake and start with the client, just because then the server could deny it based on the name it chooses. So in that case, we should start by sending a message, which is a client greeting, and the client greeting would be an origin. It's my name, my client. Then what its function is, it's for testing, and then a silly client. So this should work if I use the proper name. That works. But we're not really doing anything with it here. So we register a client. Here we send a greeting, but that's not correct. We should just register it and wait for greeting. And here is where we deal with any messages. For message in client ep.pending messages, unprocessed messages. Though now unprocessed messages is from a different thread. Well, they can only be added or removed, which I think is atomic operations, so I don't think I have to worry. But I should probably do something instead that is like, while there are messages, we pop one. Incoming message. So we got that message there, which is a client greeting. So if client ep.registered, if it's not registered, then we need to assert that this message is of client greeting. Let's instead do if it's registered, else assert not. And here we should make sure we don't have a client with this ID, msg.origin. So now it should put that in the, because we need like one lookup table for the ID and another lookup table for the file descriptor. So we should either send a greeting back, or if it's already connected, we should send a problem back. So maybe we should integrate or like implement this already. Client origin lot. I guess we should be, yeah, route origin lot. From routes import client route. Routes. So the idea with routes, the idea to have a routes object is just that in the future maybe we'll have multiple hubs and they could connect to each other and we could sort of mesh them in some way. But before that we'll just have like a client route. We'll just have like a local client. From routes import. Well, let's import routes as R. So we'll have a local client, and then we'll have the client there. Self.client equals client. There is not much to it than that. Route origin lot. And this can only happen here, so we don't have to worry about threading. If msg.origin in route origin lot else, then we send a greeting and we also reserve it. So route origin lot msg.origin equals client EP. Actually, maybe this one should also have some info. That's the endpoint. Why do I call it client? I should probably rename these things a bit. Endpoint, self.function, self.id, id function, endpoint, id function. Did we have more things? Client greeting, origin function, description. Self.description equals description. So we'll have a local client of these things. So we have the client EP, then we have the msg.origin, msg.function, msg.description. And here it turns out that we can't do this. We'll close it. I'll first send a message and then close it, I guess. Or shut the VR, perhaps? Well, we'll close it. We'll see if that works. Server decline. Or like server error. Server ID, then we have a just an error string for now. Client name already in use. So we need to create a server error message. Server error, origin, and message. Error message. Then we need to also be able to serialize that, which is here. E origin error message. Server error origin error message. And then the other way. server error. Origin needs to be string and error message need to be a string. Error origin error message. That may be all the things. Oh yeah, we need to also the endpoint if it has registered or not. Or should that be the... No, it should be the route thing, I think. Registered. I guess it needs to be on the endpoint because we don't have the route necessarily at this stage. Self.registered equals false. So here we can set it to registered. Registered equals true. Alright, local client. That's from the routes. Client connected, client disconnected. Oh yeah, but did anything else happen? Let's just wait here forever. Because now it's busy there. Then we can run another one. It didn't mind. So it sends this message. Sends the greeting there. So greeted new client. Or we have turned away client. Greeted new client. Okay, that's good. Then we'll do another one. Turned away client. Okay. So I guess the problem is that we don't actually read the response from the server. Which is fine. So we need to do this thing. Result. Oh yeah, because we never unregister it. I think this is sort of a good point for now. I need to get to some of my electronics projects. So I need to stop this project. Made some progress. We'll have to work on registering client IDs and unregistering them next. So the next thing will be, well, I need to do some preparations for that. Do some electronics prep work there. Already have the microscope set up. Alright, so the microscope needs to... First of all, do I have power for my laptop here somewhere? Where is my laptop power? Oh, there it is. On the floor. So power and Ethernet and USB. Now if I put, yeah, I can probably fit an HDMI there too. We need a monitor. It's too bad that the monitor I have here is kind of big. I mean, it's nice, but it's so big. But I guess it should probably live up there. There's so much other stuff up on that shelf for now. We're going to use this monitor here. Uh-oh. My phone makes sounds and vibrates. Alright, I have like 8 minutes until I need to deal with the laundry. There's so much random stuff up here, it's crazy. I need a little box or something for all the random stuff. I'm also getting very hungry, so I should probably have some... Probably make a note of that for now. So I'm sort of here, but sort of not. The way I like it. Yeah, I should at least put the food in the microwave while that is cooking, I can find out where I want to put all the stuff that's in the way for the monitor. I'll just heat this on the cooker instead. Put it on 40%. A cat showed up, and she has no food either. so disappointed when I gave her pellets. But she'll get the good stuff in a bit. Ah, found a little bin to put the stuff in. So much stuff. So much small, weird, expensive, different, random things. I guess soldering things should probably not be taken away. I wonder what this key is for. It's not for that cupboard. Little adapters and circuit boards. Tiny screwdrivers. I might need that one. Oops. Silicone grease, that's always nice. So do I want the monitor straight up there perhaps? Like if I'm sitting here, looking up there, because I don't want the microscope itself to be in the way of it, so I should probably clear out this area right here. Oh yeah, those are pieces for mounting the mirror on the wall that I've planned on doing since I moved here. Oops, what? Some battery cells. They can live in that thing there. I'll put these random stones over here. Another little battery. Flammable gases. I'll put it by the flammable liquid. Alright, made some space for the monitor. And got another box of random stuff. Can't all be winners. Oh yeah, still. Ah, forgot to wave at at the co-working coworker. I don't know what you call it. Participant. This would be really nice. Though that monitor is kind of dusty, but we can fix that last. So we'll need some power. I think we have used like all the outlets under here. Always need more. Is this one, will it reach up there? I guess I can take from up here. Actually, it's a bit short, isn't it? Well, maybe. It's not ideal. I'll have to make a better solution later with a longer cable or more power strips. Actually, we can start some stuff already. Well, I did want to hook that thing up to the laptop, I guess. So we need an HDMI to dang it, don't do that monitor. HDMI to DVI. Oh no, my alarms. Everything at once. Got another message. No, it's just an old one. Did it stop my music and doesn't start it again? No? Ah, I just accidentally muted it. Alright, I needed an HDMI to DVI, something I've seen many times. I know they exist. So here is the DVI to DVI, and the VGA, HDMI to HDMI, HDMI to HDMI, HDMI to HDMI, DisplayPort to DVI, VGA, DisplayPort to HDMI, DisplayPort to DVI, DVI to DVI, HDMI to HDMI, HDMI to... No, this is DisplayPort to DisplayPort. Where is my... And here's another VGA. And here's a long power cable. That's nice. I must have not put it back since I used it the last time. So it should be nearby then, I would suspect. Kinda hard to see if it's on the desk because there's so much crap on it. Ah, here is an DVI to HDMI to mini something. Mini HDMI? Or is it micro display port perhaps? I'll put it there for now. This cable isn't that long, which is slightly worrisome. I may have to move the laptop a little bit. I do have another HDMI to DVI, but it's like 15 meters and barely works. So I don't want to use that one. Like it gets weird artifacts unless like everything is perfect, which it never is. I don't think my laptop has ever had this many wires connected to it. Should get a dock for it. For the microscope to operate properly, we need the wide light. Can turn off this light. We have some sort of network. Our IP is 116. So now I need to prep work. Start to local video playback on laptop. Set up multicast on laptop for microscope. Set up screen recording of monitor stream back to laptop. And that's the question then, should I have my YouTube monitor, which has a terrible delay, or should I have my real-time monitor? I should probably have my real-time monitor, but it would be nice to also have some sort of interaction with, in case anyone would ever say anything in my chat. This is not the current project anymore. Not the current project is about to be electronics, but food, laundry, prep work pending. So I interrupt my own thoughts as usual. So if I have that laptop there, should I interact with that laptop? I guess if I have, I could switch between the monitor and the Twitch interface there, I guess. Well, Twitch, I mean YouTube. Well, that's a bit of a later problem. The first thing is it needs 2 local video playback. And we have a crazy project that can do some of these things. If we can ever find it. This is relevant for the repair work. Let's put that there for now. It's probably somewhere. Here we have video. No? Ah, here we go. So that needs to sort of be its own configuration for the laptop. Currently this thing is in the video generics thing there. We can just SSHFS mount it. I guess we can just copy paste it sort of. Oh, it's 2 does 1? Alright, I need to start SSH daemon, that makes sense. That makes it easier. Projects, video streaming. I guess we can, yeah, let's just touch electronics.py. So what do we want to do? We're starting two local video playbacks. We'll use port 9901 and 9902. And we'll start one remote video source. How does that work? I've forgotten. Okay, so this one will emit it to the remote thing. No, this is the thing that didn't work. I think. No, wait, that works. It's when we need to run MPV, we can't do that remotely because then we don't get access to certain aspects of hardware encoding and stuff. Not sure why FFmpeg can do it, but that's a different beast, I guess. So we have laptop main and laptop. Yeah, laptop main. We want to stream laptop main to the main computer. I think my food might be burning. And I need to take care of my... maybe I'm fading out here a bit. But I need to take care of my laundry, so I'll be right back with that too. Alright, while the food cools off a little bit, I need to figure out what I need to do here. So the start remote video source, that will tell the Raspberry Pi to do stuff, but we don't need to do that from the laptop's point of view. The laptop only needs to start 2 local video playbacks. And this sources stuff, where do we use that? We only use it in start remote video source. I guess we can handle the microscope here, so it should go to 9901. Yeah, because that means it will go here. That's the intention here. I need to name these better, because start remote video source should really be tell remote video source to send data to me. So this will be the microscope, and this will be monitor not yet implemented. So yeah, let's, I guess local IP here needs to be 116. I guess that thing doesn't really have, it doesn't have the permissions to get there. So I should do that on the other one. But that means that, oops, that the start remote video source, we should add a feature for that. And now we're getting into maintenance hell, because now I have like multiple versions of this project. Dest. Then we don't need port, just only need dest. I guess we could do dest port. Then we do dest there instead of local IP. So that's a small change. But this machine can talk to that other machine. So we'll do a little thing at a time. We'll start the remote video source of the microscope. That will go to 192.116 to 116. We should be able to just say that it goes to laptop, because we know that, but that's for later. And it goes to 9901, was that true? Yes. So we should call this one start microscope to laptop. So then we start the thing on the laptop. Then we run start microscope to laptop. Nice. Oh yeah, I need to tell my laptop to have multiple monitors. So I want HDMI 2 to the right of EDP1. Nice, so now I have the microscopes just straight in front of me there. Zero latency as far as my brain can tell, but it's pretty slow, so that makes sense. The next one is to capture the desktop, which I have forgotten how you do, so that's a new thing I need to add here. And I'm going to be lazy and ask ChatGPT. We have so many different ones. Let's open a new one. Please adjust this to stream desktop using MJPEG. And whatever Xorg backend is appropriate. Excellent grab. Set frame rate 30, set resolution, primary screen. Well, primary screen, that's like the leftmost screen. If I have multiple monitors and I need to offset 3840 on X, the second monitor, it's a third monitor. So it offset like that. We can minimize that for now. So let's do start local desktop grab. Dest port. That might work. I should call this one start local desktop to laptop. We're getting a terrible mess. I mean, of course, all the functions should be like in one common one common module, and then I should just have different configurations. But I'll like collate all this later. I just want to get it going now. And we're sending this to 1902. And we'll open another one of these. And maybe it will work. Start local desktop to laptop. Bam. It ended up in the wrong screen, but that's fine. It looks kinda terrible though. But I guess it's good enough for my purposes. There's probably a quality setting. How instant is it? Like if I shake the mouse over here. It feels pretty instant, that's good. So now I can see my monitor here. Next step is I need to broadcast the laptops. The laptop has two cameras that needs to be broadcast, which we could probably start on the laptop. And we do have like the start remote video playback, but let's make a start local video playback. We will have device. Well, I guess, no, that's not the right one. Start remote video source. We want an adaptation of that one, that's local. Start local video source, because then it's better, I think, to run it actually on the from where it comes. So we get source name, destination port. So we just skip the SSH login stuff and just run the ffmpeg command. Like that. So the sources are laptop main. So it will use the extra format settings. It will use the device node. It will not care about other crap we put in there. So electronics, start sources. So we don't need to start these because they are already on. Start local video source, laptop main, and it goes to to 192.168.291, port 9901. So we can do start local video playback. I shouldn't call it local. Start local video playback. It should be start F-Forter video playback. And what this thing does is that it does those two, but this time these ports are instead going to be laptop face, laptop external, or like electronic, yeah, that's laptop external. So we can start those right away. Forter video playback, so that's two of those. So now we only need to do start these two. And that was laptop main and laptop streamcam. So when I run this on laptop, it should pop up more videos around here. I only see one. Where's the other one? Did one break? I have one running. Did something break on this end? Cannot find a proper format for MJPEG. The video driver changed the video from 1920 to 64360. I must have selected the wrong freaking camera. E4L CTL list, or is it like all? Org. It's actually running the stream cam on the wrong one. I think they loaded in different order this time. Can just get the okay beacon size. Oh yeah, list devices. Ah, here we go. So we need dev video 0 is the stream cam. Stream cam. That's dev video 0. And integrated camera, probably video 2 then. That's not laptop IR, that's probably 4. Laptop main is probably 2. I'm just guessing a little bit here, but that'll probably be fine. That's why I need to make a better system for this eventually. What? Okay, but before we start these sources, we need to make sure that we don't have problems here. That's the microscope. One of these is probably broken. Effort or video playback. Yeah, that's the one that is broke. Do we have any netcats? We have that old defunct one. We do have one on 9902. We should probably not have that one here, because that's the one we want the laptop to send over here. So let's kill that one. Alright. Now we can start the video playback. And we can start sources. So that's the laptop face, and that's the electronics bench overview. I'm just going to make them a bit smaller for now. Haven't really decided how I want to lay things out yet. I just want to make sure everything works. I forgot one of the most important aspects of this. The microscope. Right now it goes to the laptop and displays there. But it should do more than that. It should actually multicast from the laptop to the streaming computer. Alright, so that means we need to kill the microscope feed on here. This terminal is broken. So we were running electronics, which is way not very good name. So electronics right now, it starts 2 playbacks. That's not the one. And then we have start sources. Oh yeah, but the electronics now, one of these playbacks is not on anymore. So I would have to kill the other one. But if I kill the other one, then I also need to kill that stream to that one. It's never easy. So it's the microscope want to start. So we'll comment out that one to really make this into individual commands. Python electronics.py. So now that stream is ready, but we need to multicast that thing. So we'll do electronics multicast, which will take, it will listen on 9901, then we'll send one to localhost 9901. That doesn't work. It will have to listen on 9905, send one to localhost 9901, and also send one to here on 9903, which we haven't also started. 9903. So we need to start that one. Is this one ready? Alright. Start efforter video playback. That one starts that one. And here we have another one. Who should tell the Raspberry Pi to start? Oh, that has to be that computer. And I did have a thing for that one. Start microscope to laptop, right. But now instead of sending it to 9901 as we did before, we need to send it to the multicast receiver of 9905, which we need to start first. Right, that one is started. So now we should be able to run this one. That will send it to 9905 on the laptop. Oh no, this is wrong. It shouldn't send this to 116, it should send it to 91. Right? Yes. So I need to kill process 979. Then we start this stuff. I don't know why it messes up my terminal. Start the multicast. This thing is configured. Start this thing. Start microscope to laptop. Alright, so now we have the microscope here and possibly also on the laptop. Alright, what a freaking setup. So I have this camera, I have that camera, I have the microscope, I have that camera. So when I sit and work here, I can face if I had an audience, and when I sit here I can also face if I had an audience. This monitor needs to be tilted down so I see it. Yeah, it's a pretty good setup. And I would sort of like a monitor stream too. I wonder if you can tell. Oh yeah, but currently I do send OBS. OBS is sent out on a virtual cam that I use with Discord on the co-working space. But I should really take that to a multicast that sends one to Discord and one to back to my laptop so I can have monitor in real time. Video juggling is so complicated. Some food, some coffee, and then we're sort of ready to go. These are a bit broken. Then in the future I'll add, let's see, is this even visible on any of my monitors? Yeah, I guess this one sees it. I'll add a control panel here so I can adjust saturation and other important microscope parameters right here on the microscope. I do think it turned out pretty stable. Like, sure, if you tap it, but like if you tap the base, it doesn't move too much. You can also do it pretty well close up. If take this one down as far as it goes. And then we switch this around. Now if we can get even more, I think there is like a sweet spot and you can pass the sweet spot. But then the focus distance becomes very tiny, I think. Might be too dark. Oh yeah, there we go. But to get there, we need to be much closer and it needs to be much brighter. I don't think that's close enough. Though maybe we can go back a little bit. No, we can't. We can go down a little bit. Is it that close, really? Cat better not steal my chicken. Oh, there we go. Yeah, it's too dark without... What are we even looking at? Yeah, it doesn't feel very stable at this resolution. Oh, was that blue thing a resistor? Yeah, it was. So we need to get even further down. Oh, there we go. That's a digit. That's D2, right? No? What's that? That's an R. Here we got D1. It's like hard to adjust this knob because when I turn it, things move more than the amount I need to turn it. Though I guess if we go too far, we can always go dial it back a little bit with this fine adjustment. Like even the text feels pretty dang deep here. Yeah, that's some deep text. That's interesting. Like if we put a ring on here, we could do some interesting 3D mapping by illuminating it from different angles. Yeah, this is too close. We need to switch it over to the other mode, which is like there. That's the other mode when we're real close. But then we'll also take it up. I guess it has like two places it will be in focus. But it's not as much in the way if it's the far away one. Oh yeah, and then we also need to like, don't need to have it all the way up there. Is it even more than this? Seriously? Ah, this can't be right. Never had it this tall. Yeah, nope. Can't find anything there. Oh, hey, what happened? That's almost great also. Yeah, that's pretty good. I guess it's probably still on up here, but not really focused down here. I'd have to zoom in on the digital image to be sure. That's also something I need to add later, like, oh crap, I need a new battery for my headphones. BRB? Ah, I just realized I wasn't really sharing the microscope. And here is the overview, and I think I'll just have the face camera like up here or something like that. Yeah, I think that's pretty good. Yeah, so the post-processing I was talking about is that I could have it so that that we can detect if we're in focus or not and show that and other helpful things. I don't really know how that capacitor feels, so I might switch it out, like the blue one. I'll probably switch the C2 one as well. It's a 100 nanofarad one, so I probably can find one. these resistors here had a bit of an interesting color bands. Like they have 6 bands, which is unusual. I should increase the brightness a little bit, I think. I can change the exposure rate bias. Or maybe set it to matrix metering so it will pick up on those highlights with the screws there. Though that would make it darker, I don't want that. I could also change it afterwards. But that doesn't help me when I sit over there. Was it 37? Exposure metering mode. We'll set it to spot. Made it a little bit brighter. And we can change the bias. Take it up a notch or two. Auto exposure bias. Yeah, I think that's better. Maybe 14, is that too much? 13 is probably good. I don't really like the compression quality here. I don't know if that actually does anything. I'm not even sure it's using. I'm not sure like if the JPEG controls affect the MJPEG controls. Oh, we can set the video bitrate. It defaults to lower than max. Oh, it's already set to max, is it? Gotta feed a cat, and I shouldn't have coffee this late, but I'll have a little bit. Tus, come. Tus, you know, it's faster if you don't try to trip me over whenever I walk back and forth in the kitchen. Or maybe you're just hoping that I'll fall and you can eat my entire body. That's like food for days. So you better figure out to put me in the freezer because I'll spoil. Here you go. Now where is the coffee thing? There it is. I've got some coffee. And a nearly clean mug. So part of my plan is to screenshot this so I can keep track of the components. Maybe we can put some of the flammables on the floor for now. I really need to tidy this bench up. Oh yeah, I tried to interact with the wrong computer. I guess I can remove the laundry thing now. So easy to forget what scenes are visible. No cats to step on. I've been live for 3 hours and 30 minutes, so I guess that's how long it takes me to make coffee. Maybe we should have like a nice webcam there instead of having the semi-nice over there. There's no room to put the coffee cup down. This isn't a very good thing to have it on while working on it. And this one doesn't truly go 90 degrees, which is very annoying, because that means if you put something in here and you look at it through the microscope, you get different depths because it's at a slight slope. It also doesn't go fully 90 degrees that way. But I think that could be, I think I could mod it. Like I could mill up the ball joint thing, make it a bit bigger. Don't tip the microscope over me. Right, where are we? That's probably where we want to be working. Need to go up. Is this focus? Looks kind of focus. We need to do some hose management here. Maybe something like that. Looks promising. I'm really sure where I want to have the overview one. Maybe here? Might work, though I don't really like... I think it would be better if I have this one to the right, like this. And then I move the picture-in-picture to the uninteresting area over there instead. That might be better. I guess I'll just minimize that one. Luckily can't really read anything on my laptop, not that there are any secrets there, but just think of other people's privacy in chat rooms and stuff. So I'm going to start by adding some guck here to make this less painful. And we also need to get rid of this stuff here. I see. Oh, I realized I can take my monitor stream here. Can I pop it out? Is that a thing? Multi-view windowed. Nice. No, wait, that's not what I wanted. Window projector preview. That's what I want. Then I can minimize that thing. I can put that thing over there. Now I can see both the stream interface and my local monitor. Because now I can see if this It's still a bit hard to see because it's small, but it does help a little. But that's also a thing, like I could set up way more scenes. I could have like scenes where maybe the microscope is the main thing, and then it's just picture in picture over the work desk and like my facing the audience cam. Let's start some desoldering here. Yeah, this melts so easy, it gotta be leaded. I guess that's kind of unfortunate that you don't get to see the entire thing I'm working on. Ah, this freaking solder sucker sucks. Well, actually, it doesn't suck right now. So now I want to sort of fold up those with the appropriate tool. That's not sturdy enough. Okay, that's enough coffee. I think I want a flat one, but I'm not sure I have one at hand. Should get something to put these old components in. That diode I think was okay. But I'm also kind of like, this diode has been subjected to some nasty stuff. I don't know if I want it in there anymore. Oops, there we get some of the pad. There too. But that's okay, I mean, in some of these places entire trace is missing. Right, and the connector there needs a more heat there. That coffee made me warm. Right. Yeah, I was trying to get the electric discharge. Let's add some more flux on these. See if we can clean it up with the solder wick. See if we can clean this off a little bit. Guess we're missing the interesting stuff with the big connectors. What's that? That looks like something has gotten burnt there. Some of these seem a bit low. I wonder if that's a problem, like if they've sunken in when I was messing with them. Ah, they're probably fine. Do we think that any other circuits on this thing is broken? I guess there aren't really any other ones. It's that capacitor that I feel would be nice to replace. Especially considering that the traces leading up to it are gone. Then we have the potentiometers. They are supposed to be 4.7 kilo ohms, so we can check if they are. Though I'm not sure if they connect to each other, so we don't get a weird reading. Maybe we did check this last time, I don't remember. So if I put that thing there, does that other camera see it then? Yes, it does. Almost. Not even close. Are we measuring correctly? Oh yeah, because these are connected. It connects the two ends together. But we can see that these two are in the middle, so it should be about half 4.7, so it should be like 2.2, 2.35. Yeah, sort of close enough, I guess. This one is a bit closer, so it should be like... I mean, if it's there, it should be like half 4.7. And there it should be, well, I guess it's almost like a quarter there. So like one and a half. Yeah, I think they are okay. Alright, I forget that electrolytic capacitor there that I want to replace. I really need to put my microscope on a sliding thing. I guess I can slide the whole mat back until it falls. Oh, that's a camera. That's not a soldering iron. Ah, this thing is in the way. Ooh, there you go. It ejected a component that rolled on my leg and ended up somewhere here. There it is. And it clearly marks the negative terminal. That's good. Maybe we can put this thing like this for now. What's that? Oh, that's the exhaust. Urgh. I like my new microscope setup. It is kind of nice. So D1 through D3 are like small signal diodes. But I wanted to start by figuring out why that one has so many bands. I don't remember all these things in my head. I would say that brown, the like brown from the right, well I guess it's only one brown. I would say that brown is probably the tolerance, and red is probably something like thermal something or something. Because I think gold in this case is just 0.1, because I think it's 5, 7, 2, which is, no, it must be 0.01? No, 5, 7, 0, 0, no, 572 times 01, so it's 57.2. But let's find a calculator online because we're lazy, and we'll do that here. Resistor ring calculator. 4 band, but we have 6 bands. Temperature coefficient. I wonder if that's really an important aspect of this device. I mean, this sits inside of the heater, but I don't think this sits in the hot part. Stop it! Tolerance value. So red would be 50 ppm. I don't know if that's a lot or a little. Then the tolerance would be 1%. Then the gold. What? Where is the gold? Black, brown. Where's the 0.1 and 0.01 resistor multipliers? First digit, green. Second, blue. Multiplier. Now we have a red too. We have a third digit. I mean, it's not red, because that's 5.3K, and these were like 5 53 ohms, I think. Oh yeah, we can select 6 band here, nice. So green, blue, red. Why is red capital? Who made it? Gold is a tenth. Tolerance is brown, and tempo is red. Not capital red this time. Though this red is brighter, so if any red should be capital, it should be this one. I guess that's brown. So that brown looks red to me. Very reddish brown. So this is 56.20 ohms. I've sort of been trying to get rid of my hole mounted components because I don't really use them that much. But this is an excellent case for having them on hand. Hopefully I do have some on hand. Ah, found a secret stash of LED bulbs, and there's all my tape I've been looking for. I need to remember that for next time I'm looking for it. These are just boxes full of hard drives. What about in here? Speakers. Okay, maybe they're not in here. Maybe they are in one of all these boxes that I've stacked up under the desk in a terrible mess. Oh, this is not the nicest thing. Ah, here's a box full of glue and stuff. But there are more boxes. There are always more boxes. Oh, here's a heavy box. I think it's things for curtain rails. It's probably in this heap in here. Oh, this is terrible. That looks promising. Where did it go? Well, there are some components in here, but I think I have one that's like packed, unless I threw it away. Because I was like, I'll never need hole mounted stuff, and if I do, I'll order it. And then here I am. But on the other hand, if you can't find the stuff when you need it, it's not a lot of point having it. So much crap in here. Oh, this was a heavy one. Ah, it's my... No, these are things that should go to the basement. There could be in flat boxes. I need to go and check some of my flat boxes. I do have plenty of those. Whenever I look through all my boxes, I find fun boxes that I'm like, I want to play with this box. But whenever I look through these boxes, I'm busy doing something else. Here is one box of resistors, that's good. Ah, nice. Here are some hose clamps. They should go to the basement. Here's more basement. Oh, it's raining tiny boxes. I also need to find some nice copper wire for the repairs. And I'm sure I have plenty, I just need to locate it. Here's more stuff that is going to the basement. Weird projects. Panel meters, that's always nice. Various raw metals. Pyroelectric sensors. Ah, optic stuff. Ah, they're the furniture pads I looked for the other day. They should be collated with the other furniture pads that I saw. Oh, there they are. Drill bits, that should go to the basement. And some tools. And here's more basement stuff. Ugh. So much basement stuff. Ah, here we have more resistors and stuff. And things for organizing cable. This is, I found copper wire, but it's all isolated. But I'll put it where I can find it. Oh, that's a heavy one. It's full of nuts. Alright, we did find a little bit. Of resistors, that is. Then there's all the other stuff we need. But we'll burn one bridge at a time. $100 ohms, that's kinda close. 56 ohms, where these were like 6.20. I think that will probably work. Yeah, we can always adjust. As long as the three are the same, it should work. And they are like close to 50. 47. Right, and then what was the other ones? So that's the 356K ones. Then we also had that one and that one. So that should be 1, 2, 3, which is 12K, and then 103, which is 10K. But we're going to check with the calculator because it's likely that I'm making mistakes. But these are 4-band ones. Brown, red, red, orange, gold, 12K. I found 12K ones here, even though they're not supposed to be in here because this one is only up to 10K. But that's good. 12K, and then that one, brown, black, yeah, 10K. I did see 10K in here. Do we have any nice ones? Yeah, we do have a few nice ones in there. Alright, that takes care of the resistors, I believe. Then we have the small signal diodes. So I don't think that they are special. And I think that maybe one or two of them work, so we can see what they are. Or maybe we can see what they are. They're like 4. It's so hard to read when we need to rotate them. T4148. What about the next one? T414. I think it's 8, but it could be B too, I guess. That's probably 8. T4148. Let's look those up. I keep stepping on this thing. This cable management thing. Feels like stepping on a weird electro snack. T4148. Another a good match. That's not a surface mount one. That might be it. Well, not really. Is it a switching diode? So it's a silicon one, well, up to 75 volts. But at least we got some basic. It's a fast switching diode. Diodes. There might be diodes in them there, hills. Some mixed things. Are these 100 nanofarads? What does it even say? They feel a bit heavy. Does it say 104 there? Looks like it. Might need some extra light. I want to believe that it says 104 there. But what else does it say? Does it say 25 volts or what? Doesn't it have a voltage rating? Come on. Gotta have a voltage rating. 5C. I just don't want to put in like a tantalum one. I don't know if these are ceramic or not. Probably ceramic. Just seems a bit big. Maybe we can cap meter it on my meter, but that's kind of tricky to do. Especially when you don't have like a good interface for it. Capacitor. 200 nanofarads. Boom. Yeah, that's pretty much 100 nanofarads. Right, we'll use that one in replacement of the one that was there before. So now we need a few small signals, switching diodes, and then we need this one, which is a different diode, possibly a dead diode. Let's see here. Oh, it works, 0.7 volts, so probably a normal silicon. These ones are very dead, very shorted. I think this is probably just like a higher power one. Maybe we can read what it's called and look it up. Hey, it says 5V1. It's a Zener. And it's a rather fat Zener. And I wonder if it's still working in the Zener direction. We can't measure the Zener voltage with this instrument here. Oh, I'm not showing what I'm doing. I'm sorry about that. Here we go. this instrument here can't measure a senior voltage of 5 volts because I believe this measures with like 2 volts. So we'll have to get like 10 volts and a resistor, and it's never easy. I guess we could get 10 volts from my my PC oscilloscope. But then we have to fiddle with that thing. I guess I should make myself a measurement device that have a bit better range for these things. Here we have a plus minus 5 volt adapter that I've made. We could use that to get the voltage. Then we could use one of the 10k resistors, and we can take one of the ugly ones. Oh, I see that Discord have been saying things. Not that the microscope has audio anyway. We need a shaving cord thing. And we need to close the window because it's getting cold on my feet. I'm getting cold feet. Ooh, here are nice stuff that should be in the basement. Where might I have such a cable? Oh yeah, one is used there with the microscope. Oh, here is a whole box full of them. Some are even like not properly spooled up. Boom. So now we possibly have like 10 volts here. We can verify. Boom. Yep, nice. So now we'll hook up. Oopsie daisy. We'll hook up this little power source here. We need a little screwdriver. We'll put it on the positive terminal. And then we'll reverse bias the diode here. Whap. Maybe I'm not showing very well what I'm doing. I guess I could use this feature over here. Oh, this webcam is a bit hot. I know. If this is seen here, it's kind of just like floating in the air, probably not where it's going to focus. And sure, it does have manual focus, but that would require some effort on my part. So we're going to reverse bias this diode to see if it works as a Zener diode still. Oh, this is so terrible. I should just have soldered it there. I'm just going to give it a squeeze like that. And now if we connect it to the negative terminal and then we measure the voltage drop across the diode. We'll take this red cable to represent negative. Yes, I know that's silly. Then we hook it up here. Might be hooked up now. We have to measure in two takes sort of. So we'll. Oh, this is terrible. Can we even see what's on here? What's all that light? Right, there we go. So first I want to just make sure that we got that it's connected. So we read 0, which is a good thing, because if it wasn't connected up to this point, it would read 10 volts. Then we measure the full thing, 10, so then we know that we have connection in both ends here. Now we measure the midpoint, 3.9. That's not really 5.1, but that could also be because of what current we get here. We currently have 6 volts across this 10 kilo ohm resistor. I believe it's a 10 kilo ohm resistor. 10333. Assuming that the silver there means what I think it means. Let's measure it. Yep, it's a 10 kilo ohm, 11 kilo ohm. 6 volts, 11 kilo ohm. That's like okay, so 6 volt, 0.6 volt over 10 kilo ohm. Over 1 kilo ohm. That would be 0.6 milliamps. So maybe 0.6 milliamps is not enough for this Zener diode. We'll have to look it up and see if we can gain some insights. Oopsie daisy. It's a BCX 85 degrees. BC BCX, oh come on, BCX, 5 degrees, 5V1, diode, 5.1, test current 4 to 80 milliamps, we have 0.6. B6 85C 51. So nominal is 51 at 4 milliamps. So to get 4 milliamps, we should have roughly 1 kilo ohm resistance there instead. And I think we could rustle up a 1 kilo ohm resistor somewhere. Here we go. So we'll take this. I think it'd probably be a fine one though. But let's just test it when we're already here. Keep forgetting to switch view. Gonna clamp it on there. Then we remove this one. And we hook it up. $10 across. 4.75 to midpoint. And yeah, it is. But we may not really have the right current. 5 milliamps. So if it's 475 at 5 milliamps, and it's like that other value we had. So I mean that's probably fine. Like 6 milliamps at 10. No, sorry, yeah, 0.6 milliamps. We had like 6 volts or whatever it was. No, was it a lower voltage? I already forgot what my measurement was. I guess I can have a little look around, see if I find any other ones that have not been in this situation. Ten microfarad. What was this capacitor? It was. Yeah, let's throw it on the floor. It was 470. found 100. 220, but that's 16 volts. This was 25, right? Yep. '4148 switch diode. Nice! That's exactly the one we want. I wasn't even looking for it, it just ended up in my hand. (2200 microfarads). So now I just need that capacitor, and I think oh, and also I want to look for another diode. I do have some like kits just overflowing with diodes, so it's possible that one of them would actually help here. If I can find them. Transistors. I pull it out of somewhere, now it doesn't go in there anymore. You now live here. I don't think I put it in here, but who knows? I've been close to throw out all those diodes many times. Maybe I finally did. Because I was thinking, why would I need so many diodes? Especially because a lot of them were pretty old and yeah, like a bunch of vintage diodes that I don't really know which ones they are. But it's sometimes hard to convince the hoarder in me to let go, so there might be here. I need more light. Oh, these. Okay, there in that box there were a few random scattered poor diodes. Nothing blue. It could also be that I decided to free the container, but that I transferred them all into a bag. In which case, I should have a bag of diodes somewhere. And I have a few different stashes where it might be. And it just might be that one that I can't really reach right now. Well, unless I move a bunch of stuff, which is never fun. Let's take this tape deck. And this UV exposure apparatus. So many old projects. Oh my. This looks like bigger components. So it's over there, under that computer and that microwave oven. I really need to throw out some crap from here. These look like even bigger components. That looks like other stuff. Hopefully that won't collapse. Hopefully the cat isn't walking on it. Found some capacitors for later. I also think, yeah, I should have like some bags of assorted components. Here's one. Doesn't look much like diodes in it though. Actually, I should have like some bag with mixed diodes in it here too. Those are probably self-fading LEDs. Yep. Which I should do something fun with. I should just have titled my stream like looking for things. Looking for things while mumbling. Is this just cable or are there stuff here too? That seems to be cable. What's that? Oh, that's crap. It's always crap. Never good stuff. I suspect I put a lot of the components in the same place, but then promptly forgot what that place is. Ah, here's more lab cable. That's good to know. I know I already looked through all these, but I was kind of looking for a different thing then, I think. Maybe I didn't look as carefully. This is an outrage. Maybe the cat knows where they are. Well, let's check for that capacitor for now. In the capacitor box. I said 470. 470, yes. But these are 16 volts. That one looks terrible. Yeah, not much luck in this one. This is such a waste of container space. But I do know that they have some... No, but they're probably also in one of those boxes where all the components are. Is it... What's in this thing? Those are circuit boards in that thing. Circuit boards, lamp projects, and old other things. I'll check my flat boxes again. I think I should have capacitors somewhere. The cat is doing parkour between like the vinyl player and the loudspeakers and stuff. Just a matter of time until she'll break something. These 471s are 10 volts. Here's a 40 volt one. It's a bit big and old, but it should probably work. Let's use that one. So now the only concern was if I wanted to replace that Zener diode. But I don't think I'll find a suitable one, and because that one doesn't seem to be broken, we'll just use that one. Though this capacitor is physically much larger. Which could become a problem. Was it really 25? Yeah. I'm going to see if I can find one. I could probably find one that I could steal on some board. Okay, we can unhook this thing. I just hope that when all this is fixed, that that the CPU board doesn't have any problems with the input of these signals. But because the CPU works and everything, I do have high hopes for it. So what would have a 470 microfarad 25 volts capacitor? Probably something like mid-sized analog thing. Probably not any of these power supplies. Well, not 25 volts, would it? To 2016. I'd go with a 16 if I knew that they wouldn't be supplied or subjected to higher voltages, but I don't really know. Here's something from a TV, it looks like. That could have something. This one is too old, I think. Lots of diodes on this thing though, but I don't think it has any nice Zener ones. Something has been hot on this one. 35,680. I mean, that's kinda close considering the tolerance on these things, but I don't know. Oh, these diodes are so ugly. Instead of a really fat resistor, they have a whole bunch of resistors in parallel. 25, 3, 30. That is so close. But I don't know the purpose of it either. Like, it's probably a smoothing capacitor or something. I'll put this one aside in case I decide to use one of those. No obvious capacitors hiding here in plain sight. Yeah, all these things will be so much nicer once I've finished tidying up here. That's like an ongoing project that is not ongoing very fast and kinda intermittent. We'll go with the 330 for now. And then measure it on site, see if things look good. Otherwise we'll have to come back to it. I think that's one. Something like so. I'm worried that I'll have cables going into the soldering iron here. We'll put some flux on to make it more compliant with our demands. One drawback with this one is I can't really lay down the way that the original one was. I don't know if there is any mechanical constraints in where this lives. I don't think I can make it lay down there. Nope. It will have to stand. So that's a potential issue. Actually, it's taller than anything else on this board. Uh, so I should probably not put it there. Either I have to make the pins of it longer or need to find one that isn't cut. But let's just put that thing aside for now and solder some of the other things. So we're going to put this, again, put this thing in here perhaps. What's a nice way of holding these things? Need a double jointed vise so I can position things easier. We'll put that one there. Something like that. Then we have the 356K resistors. I mean 56 ohm resistors. It is slightly worrisome that the other ones were so precise, 56.2. But because this is intended to measure phase imbalance, you'd think that having 3 of the same would probably be good. But I guess we'll notice. I don't really know how we should test this also, like, because this is for a heater and this is for measuring if it's out of phase. Well, not out of phase, it measures like if it's an imbalance in load. And the idea is that if the heater detects an imbalance in load, it will slowly go down in usage until it's been resolved. And that's to prevent tripping the main breaker, which can have dire consequences if it's the winter, because that could lead to pipes freezing, which could lead to the entire house being destroyed. And you don't want that. I wouldn't want this guy's house to be destroyed. Then we have the diodes. Now we get like one spare diode left here. We need to keep track of this whole bag for one tiny diode. being somewhat rough to these diodes, but I do have one spare. Then we have the Zener diode that will use the old one. Shave it a little bit there. Then R4 and R4 and R5, one of them was 12, one of them was 10, but which one was which? Lucky I took screenshots. Did I put them in here? There we go. So R4 is 10. Putting in the same direction as that one's, just to make it look good. And then the 12K. It would be so interesting to get to the site where this board sits and see what the heck they connected here. I don't think they connected current transformers. They typically don't evaporate traces. I think we should probably solder D4 first, because that's the one that's likely to escape here. Nice, there are still things to solder it on. Well, at least on one side. And I'm not going to use leaded to solder this, because I don't really want to deal with that stuff. Oh no. I'm actually going to cut off a little piece to make it easier to deal with. course trickier to solder. Harder to heat it up properly, but it does help with some external flux. So let's put some on. Let's do that one side first. Yeah, that's much nicer. Turns out that things get hot when you solder them. Do I have a nice little thing for cutting these fairly close to the board? I have a non-nice thing for it. Oh, that's a very non-nice thing. This looks promising. We'll have to do. The drawback of folding them over like this is that they can go over other traces. And when you force them back, you can induce mechanical strain. But now when we have soldered them in one end, we can always fold them up a little bit. And now these are like big heat sinks, so if we also cut them down a little bit, it would be easier to solder them. We'll put some guck on them all, some flux. I figured I wanted to replace components before replacing the traces. And I'm going to replace the traces with copper wire. And then I'm going to fix it all with some plastic spray. Well, I guess, yeah, plastic spray. Protective varnish. I think you can also call it, I forget, compliance something. I'm not sure. Conformative. Conform. I'm not sure. Something like that. Conformative coating. It's kind of disgusting here now because of the excess flux. I should get a new small side cutter. This one is kind of messed up. So let's clean it off a little bit. Doesn't look too bad. How's that? Well, it looks pretty bad in the microscope. But maybe it looks better once it dries up a little bit. I don't know. Looks kind of messy. And here the other side. The circuit board is so cold and nice. And icky. Alright, so I need to find some good thing to replace those traces with. This thing doesn't, like, I can't get focus in that end and that end because the board is tilted a little bit. Maybe I can find some midpoint, something like that. Is this a single wire? Is it bare copper or is it tinned? It's tinned. Do I want tinned or bare? I'm not sure. I think I want bare, but I don't actually know which is best for this purpose. Oh, I have a bunch of, but that will be tinned. I was thinking I have a bunch of phone wire. But this here looks kinda like it might be something. Is it a reasonable thickness? I think it's pretty good. I mean, it's much thicker than the... It's sort of the same thickness of a trace, but these are round, and the traces are like... I don't know, maybe it's like 35 micrometer of copper, so these are much, much thicker. Or like, yeah, they have much, much more surface area. Like, crazy amounts more. This is a great way to like cause really annoying problems with your nails. I'm going to start by that capacitor. I guess that's a bit outside the view. Maybe I can just warp. Maybe I can just hurg. I'm also going to pre-tin this a little bit. This is a great way to burn yourself. Try to put it there on the side, sort of. It's fine that I covered the hole because I can open it up when I'm done laying down this track. I really don't like having like a what would you call it? A knurled surface, like some nice pointy. I guess I should order some like jewelry pliers. I do have some artery clamps, But they also have these knurls, so they're great for holding things, but not so nice for uh, carefully bending things into place. And this is my most my thickest tweezers, but the ends are still a bit like that, and I don't want to risk breaking them. I guess I can maybe use like the back of them, but I don't really see what I'm doing when I'm doing that. And here I think, I mean, here we need a sort of a sharp turn. Oopsie daisy, now it came loose. That thing will become a bit more stable once that capacitor is there, and also when the conformative, yeah, the protective coating is on. And where we still have some copper left, like here, we can anchor it to that old trace. And here, when we need to pass a thing, just try to like pass it on a side that is further away. Like this side is a bit tricky to get there. Take the other side there. I think I'm going to start by trying to get it down here a little bit. That didn't go too well. Let's put some flux on. That's like magic in a syringe. And also like hold it down a little bit. Guess maybe I got a bit too much on there. I forgot to put magic on that one. Nice. And here I'm probably going to take the outer one to try to like, yeah, maybe try to take this inner one to be slightly closer and the outer one slightly further out. As long as we don't get interference there. And maybe we'll just go like the long way around here. This is not something I do a lot, so I'm just improvising here a bit. This one is supposed to go around here, but like we could take it straight across if we put something under it. So we'll clean it up a little bit. Oopsie daisy. And while that evaporates, we'll find the expensive tape. Which is probably mostly expensive because I bought it from a professional place and not just eBay. I haven't really been keeping it in a professional style though, so it's a lot of like icky stuff on the roll. I can brush it off a little bit. Some polyamide tape. Take the cute scissors. Luckily the trace under here is still whole, or I'd have to repair that first. Guess it's kind of hard to see on the camera here because of the reflections. And that's the end of that one trace. So we can cut it there. Put some flux on and hold it down a little bit. I'm also going to try to attach it a little bit in those trace residues there on either side. Put some flux there and some flux there. Oh, that's ugly. I'll use the undo function. Well, I've previously undooed leaded, so I should have cut off some piece of that. That one is tricky, like it wants to go through there, but that seems like why make it hard on ourselves? Like let's put some tape here and just take it across here instead. I mean, going here, so we could potentially just get at it this. Nah, I think that's cross here and then the outer edge here. And I guess we could like go through here. We'll start, see where we end up. I'm going to start by pre-tinning the end so I have somewhere to get a good connection to start from. Then we take some tape. may need to secure this with something here. It's a bit flimsy. I guess the protective coating will probably put it in its place, but I wouldn't want it to move about too much. We'll take it on the outside here. Just swings all over the place. We can secure it with some tape here. And we could secure it here too, because we already soldered that part. Or maybe we should secure it with something else, I'm not sure. Trying to force where it sticks up. It's better it sticks up a little bit here than over here. But it's still way too flimsy. Maybe I should actually use some cyanoacrylate just to secure it right there. Or maybe I should use a different type of glue. I'm not really sure what's the best here. That plastic coating, you can solder on it, so you could potentially coat this and then solder, then coat it again. I'm going to try to put some tape in some places for now. And if it doesn't work, I'll have to rethink it. Okay, we'll take some more tape there. Not sure which hand I want to use for what here. Not sure how this will end up once we put the plastic spray on. It does feel, well, not that much more secure, but maybe a little bit. Guess we can put some there too, but I don't know. It just slides on here, maybe because it's a bit of an oil film from flux and other icky stuff. Okay, so here is a tricky bit too, because here some of it has exploded, though I guess if we sort of wrap it around like that, we'll get both the pin and around the pin. Maybe I'll just do something like that while I solder it. Where did I put there? It's a lot of heat sinking going on in here. Quite a lot. Luckily we're not dealing with high voltages as far as I know, so you don't have to think of those pesky isolation distances as much. We have one that goes like this. Okay, let's first tin this a little bit. Yeah, this won't go without flux. And it doesn't have to follow that thing, I mean it can go here. We'll take it on the left side to give more room for that other thing. Feels like I'm taking shortcuts. I wonder why they routed it like that anyway. Have like that little thing where all these free meet. It's like, yeah, we have such fast signals here that we need to like split them up in this one point. I don't know how I would have done it though. Not saying it's wrong or anything. Though this tool is wrong. That's terrible. That thing won't move. So now I have this one left here that goes in between there, but maybe we can go the long way. So let's start with this one. We need more wire. What time is it? Where is time? There is time. Oh, it's like 10:30. Should probably sleep soon. It's stuck. Maybe we don't need to pre-tin it if we just pre-flux it. I wonder if I could test this. Like, I don't really know what voltages these current transformers are supposed to give out. But that Zener is probably for clamping it. So it should probably be under 5 volts. And also because it goes into a 5 volt system, that makes a lot of sense. Oh, that's not too bad. Well, except for how utterly bad it all is. Right, and then the next one will go from here, here, crossing these things. We'll put some tape over there, and then just like sweep there somewhat nicely. Too many tweezers. Something like that, perhaps. Too bad language models and multimodal models aren't that good yet. Would be kind of nice to just take this photo and upload to the cloud and be like, hey, did I connect all this right? Did I miss anything? Probably should verify connection in some of these places that might be a bit sketchy, like is it okay in between there? But we have from the capacitor, it goes there, and then it goes there and around, and then it ends up there, like that, and that's the end of that line. This one has let go here, little mean thing. Goes over there. Go between those two and up there. This one goes over there. Oh yeah, we forgot to take it over there. Is that the only thing we forgot? Well, I say we, but obviously it was all my fault. I think I'll just replace this one with one that's continuous. It'll be much easier. Going to do some solder sucking there. I think we're going to take it something like that. Something like that, perhaps. Ah, this freaking thing is terrible. Oh my. Look at that. Poor thing. I think I'm better off like grinding the tip off and make a new tip a bit further in. Alright, so now this one goes there, and it goes all the way over there. Yeah, I think with enough coating this just might be okay. Maybe we can squish that one now. Maybe we can squish that one now. Anything more to squish? Need to put that capacitor in place. I'm unsure how good connection it has over there. So let's fix that to be better safe than sorry. We need a scraper. I saw a tiny screwdriver that looked suitable for that stuff. Not this one. One that didn't look like something I'd care about. Yeah, this one. That's one mistreated screwdriver. So let's have a look a bit more here. Actually, we could just attach it all the way over there. Nah, I'm too lazy to do that because then I need to replace the solder. And also those potentiometers might be sensitive to heat. So we'll just try to like get it there somewhere. Probably need a lot of this here. Well, a lot, a small area, but I think it got a connection there. I guess the best way to test this would be to hook up the current transformers and hook up this board and just measure things on it. See if it seems reasonable. I'm going to try to rinse it a little bit. But I'm not going to coat it tonight because I'll have to do that outside and I'll rather do that in the daytime. Maybe we'll do something like that. I need a bigger, we're gonna need a bigger can. This was some chemical experiment, but now there is a bunch of dust and cat hair in it, so might as well use it as the use it as a sink or what to call it. So now it's rinsed. So it can look a bit icky in other places, but maybe I can carefully brush off. Yeah, it does feel like it has like a thin layer of something on it. And it probably needs to be rather, well, somewhat clean, I guess. But I'm afraid to use the brush here, because I'm afraid I'll just brush the tape away. But maybe I can do it really carefully. I will also have to protect this connector here, so I'll have to put tape over there before I coat it. But that gives me an opportunity to hold it there. I kinda don't want it to like I don't want it to like run into here in these holes. I guess I could put something over those two. Maybe I should start with that, covering up those holes. I think maybe some regular office tape might be good for that, but I'm not sure. Of course it fell down and got stuck in all the dirt and stuff here. Might as well apply that right now. The tape, I mean. some sort of razor sharp object, perhaps. Oops, that's not very thick protective coating. Just hope I didn't cut the traces, but I don't think I did. I'm going to try to do some verification measurements once it's completely finished. Yeah, that one is not staying there. But hopefully the coating will make it stay. Not sure like that's soldered there. Oh, I need to wash my dirty hands from this. I think that's enough electronics for tonight. And probably enough streaming too. I just don't want to touch the computer before I wash my hands a little bit. Oh, there is stuff all over the place. So much things and stuff and items. And I should not leave this thing to its destiny without a lid on. Well, it has been fun, and wow, it's been like a quarter of a day too. But anyway, I hope you enjoyed. Have a nice evening or morning or whatever